Welcome to the Explainer. Today, we're going to dive into a really cool reasoning method that AIs use to solve complex problems. It's a technique that basically turns any tough challenge into a mystery that can be solved step by step.
So, let's start with a problem I'm sure we've all had. Your internet goes down. You know that feeling of frustration, right? Before you even think about it, your brain just kind of kicks into a problem-solving mode. Well, it turns out that process is surprisingly similar to a really powerful AI technique.
You probably don't start by randomly checking every wire and device in your house. No way. You start with the end goal. I want my internet back. And from there, you work backward. Is the router on? Are the lights blinking? Is the main cable plugged in? See what you're doing? You're acting like a detective, starting with the mystery and working your way back to find the clues.
In the world of AI, this super intuitive method has a name: backward chaining. It's a key technique for what we call expert systems. That's AI designed to think like a human expert. And it's perfect for diagnosing a problem or proving an idea. It's all about being goal-driven. You start with what you want to prove, and then you break it down into smaller and smaller sub-goals until you hit solid facts.
Now, to really get a grip on this detective approach, it actually helps to see what it's not. Let's compare it to another method that works in the complete opposite direction.
And here's where it gets really interesting. Backward chaining is our detective, right? Starts with a specific goal, solve the case, and only looks for clues that are relevant to that goal. Forward chaining, on the other hand, is more like a scientist. The scientist gathers up all the data they can find first, throws it all together, and just sees what conclusions pop out. Totally different philosophies.
All right, let's see our AI detective in action with a classic little logic puzzle. We have a pet named Fritz, and we need to figure something out about him. The AI only has a few clues to work with.
So this is our goal. This is the mystery we've got to solve. Can the AI prove that Fritz is green? It's working with a tiny little knowledge base, just 2 facts and a couple of simple rules. Let's see if it can crack the case.
Okay, so here's all the evidence our AI detective has to go on. 2 simple facts. We know Fritz croaks, and we know Fritz eats flies. Then we have 2 if-then rules that connect these ideas. It doesn't seem like much, but for backward chaining, it's more than enough.
So, the AI starts at the end. The goal is Fritz green? It checks its rulebook and finds that if something is a frog, then it's green. Okay, so now it has a new goal. Prove Fritz is a frog. It looks at the rules again and finds that if something croaks and eats flies, then it's a frog. Great. Now it just needs to check those 2 final sub-goals against the facts. Does Fritz croak? Yep. Does Fritz eat flies? Yep. The whole chain is confirmed. Case closed. Fritz is green.
And this is just a brilliant way to visualize it. You take one big, complex goal at the top, and you just keep breaking it down into smaller, simpler pieces that you can actually prove. It's a total top-down approach to finding the truth, building this beautiful tree of logic where the leaves are just the simple facts you already knew.
All right, so this isn't just for fun little logic puzzles about green frogs. You actually see this powerful way of thinking in all kinds of systems you probably use all the time, maybe without even realizing it.
So this is the crucial part. It's all about picking the right tool for the job. Because backward chaining is so focused on a goal, it absolutely shines when it comes to diagnostics and troubleshooting. Any situation where you have a specific problem you need to solve.
Think about a medical diagnosis system. It starts with a possible illness, that's the goal, and works backward, checking if you have the right symptoms. Or a customer support chatbot. You tell it my payment failed, and it starts with that problem and asks you specific questions to trace the cause. It's all backward chaining.
So if there's one thing to take away from all this, it's that backward chaining is this incredibly focused and efficient way to untangle a problem. Whether you're a human or an AI, starting with the end in mind lets you cut through all the noise and find the clearest, most direct path to an answer.
It's really a powerful mental model, isn't it? It turns these huge, complicated questions into a series of simple, logical steps. You start with a query, your goal, and you work your way backward through a set of rules, hunting for the facts that will support your conclusion. It's this goal-driven approach that makes it so amazing for diagnostics, especially compared to its data-driven cousin, forward chaining. It just goes to show you, sometimes the best way to move forward is to start from the end.